A force of 10 newtons is applied to a 5 newton textbook to move it across the table to the right in an accelerated motion. If the force of friction acting on the book is 1.5 newtons, what is the net force acting on the book? Neglect air resistance. Draw a free body diagram and determine the net force acting on the book. All right, so first things first, we need to draw a free body diagram. You do not need to be an artist to have a good free body diagram, so I'm going to draw a textbook as such. And I know there's a couple of different forces acting on this textbook. Okay? The first one is that I've applied a 10 newton force. I know it's a 5 newton textbook. I know that it's accelerating, and I also know that the force of friction is 1.5 newtons. So let's put some information on here. First thing is I have the weight of the textbook. And so the weight of the textbook is 5 newtons. In order for this textbook to not go through the table that it's sitting on, I need to have a 5 newton force in the upward direction. Remember that we call this force normal because it is normal that the textbook does not fall through the table. We'll label this guy here too, and this is the weight of the textbook. Next thing that I know is I've applied a 10 newton force, and so whenever I draw a free body diagram, my arrows need to make sure that they are to scale of each other. And so what I mean by that is if this length means 5 newtons and I'm applying a 10 newton force to the right, this would be 5, this would be 10, right? It needs to be about 2 times as long. So I'll label this with my 10 newton force, and then if we're labeling forces, we'll keep at it here, and this is applied. Last but not least, I have a 1.5 newton force in the backwards or the left direction as my force of friction. And so that needs to be smaller than my 5 newton force. And in this direction, we will label that friction. All right, I've got a free body diagram. Now I am looking for the net force. And so what the net force is the difference between all the forces when you add them up together. So I have 5 down and 5 up, which means those cancel out to give me no net force up or down. On the right-hand side, I have 10 newtons. On the left-hand side, we forgot to give this a value here, we have 1.5 newtons for friction. And so the net force is going to be the difference between 10 and 1.5. So with a 1.5 newton force in the leftward direction and a 10 newton force in the right direction, I'm looking for the difference between them, which is 10 newtons minus 1.5 newtons, gives me a difference of 8.5 newtons. Now remember, with forces, I need to give a direction, and so this extra 8.5 newtons is in the rightward direction. So 8.5 newtons to the right is my net force. And so part of the reason that we draw these arrows to scale is so that when we look at our picture, this 8.5 newtons to the right makes sense when we look at the way that we drew. Okay? So make sure that as you draw your free body diagrams, you're labeling everything, but you're also making sure things are to scale.